Hey everyone, go ahead and open your books to page 231. We're going to be in lesson 15.2 talking about functions with inequalities. So we're going to graph and analyze functions on the same coordinate plane and write inequalities to represent real world situations. So if you remember from first trimester, we had less than, greater than or equal to, etc. So we're still talking about Travis and Roy, and Travis knows that his first graph represents a model for an ideal travel scenario. In reality, he assumes that his average speed will be lower because he will need to stop to refuel. He also decides that he must account for concerns about road construction and traffic. So experience tells Travis that his average speed will decrease to 45 miles per hour. His ideal scenario from lesson 15.1 is shown on this graph right here. On this same graph, we are going to draw a new line together showing his distance from Dallas based upon his assumption that he is going to maintain a slower speed. No longer 60 miles per hour, but only 45 miles per hour. So I know that it's going to take him a little bit longer. So before, our rate of change or our slope was negative 60 because we were driving 60 miles per hour. Well, right now, today, our slope would be a negative 45. Negative 45 miles per hour. Let's look at our graph. My graph from 0 to 90 is increasing by what? What's halfway between 0 and 90? It would be 45. So that's nice. It makes it easy for us to graph if each box is worth 45 and my slope is also 45. Let's continue to fill in our numbers because we're going to need them. 90 plus 45, 180 plus 45, 270 plus 45, 360 plus 45. So what's the total distance again from Pecos to Dallas? Because we're still traveling from point A to point B. It's still 450. And I'm going down 45 miles per 1 hour. So go down one box over one. Down one over one. The whole way. And it's really important that you use a straight edge to connect these dots. You want this to be as straight as possible. Because these numbers are going to be important to us. Write an equation for the line you drew in question 1. So let's start with distance equals, D equals, my slope plus my y-intercept. So remember, usually we would use y equals mx plus b, but we're using D for distance and H for hours. So what's our slope here? How fast are we driving? We're driving 45 miles per hour, but because our distance from Dallas is decreasing, our line is going down. So we have a negative slope. So we're going to say negative 45. Although when we're talking about speed, we use positive numbers. We say we travel at a positive 45 miles per hour. plus, what's our starting distance or our y-intercept, our beginning point? It's 450 miles, so that has not changed. Travis can average anywhere between 45 miles per hour to 60 miles per hour, and you can see that on the previous graph. So I'm going to go back to the first graph, and what we're going to do is we are going to sketch a vertical line at h equals 3. Then we're going to highlight the portion of the line that gives all the possible distances from Dallas after 3 hours travel. So let's go back to our graph. And I'm going to draw in a vertical line at h equals 3. And it said to highlight the portion of the line. So that would only be this portion right here that represents all the possible distances. Okay, question A is answered. I've graphed it, I've highlighted it. So letter B, how far might Travis be from Dallas after 3 hours of travel? Explain in your own words and write your answer as an inequality. So let's look at the endpoints here. Okay, let's look at the numbers. Where does my red line, my red vertical line, intersect? Here and here. So what's the lowest number of miles? 270. What's the highest number of miles? 315. Okay, so in my own words, it would be anywhere between 270 to 315 miles. So the endpoints were 270 and 315. Thus, the points of the segment represent all the possible distances away. So anywhere between 270 and 315. But to write this as an inequality, it's similar to how we write domain and range. So my low number is going to come first, so 270. Then my inequality symbol, we're going to use D for distance, 315. So our low number comes first on the left, my high number goes last on the right. All my possible distances are in the middle. So my distance is either greater than or equal to 270 or less than or equal to 315. Anywhere in between. Make sure you have the equal to lines. We could be exactly 270 and exactly 315. Okay, now you're going to do the exact same thing over and over and over again for question 4, 5, 6, 7, etc. Okay, so keep drawing in vertical lines and look, load high. Where do they intersect? So question 4 says, on the graph, sketch a vertical line at h equals 5. So to the best of your ability, you're going to sketch the vertical line at h equals 5. Highlight the segment where they intersect. Ooh, and these aren't perfect. This doesn't occur at a good intersection point, so you might have to guess. You might have to estimate, guesstimate. It's okay if my numbers are a little bit different than yours. That's okay. So go ahead and pause, and I want you to try these questions. You can do it. How far might Travis be from Dallas after 5 hours of travel? It's okay if your numbers aren't exactly like mine. Okay. So my endpoints are at about 150 miles to 225 miles. So he's at least 150 miles and at most 225 miles from Dallas, away from Dallas. Okay, and you can write those words out. He's at least 150 miles and at most 225 miles from Dallas. Now, sometimes I get 140, 160, 165, 155. It's okay if your numbers are not exactly the same as mine. So if we were to write this, it's 150 less than or equal to d for distance, less than or equal to 225. So describe what it means. What does the inequality represent? What does the line represent? Well, the points of the segment represent all distances from 150 to 225 miles. So what that means is after 5 hours of travel, Travis could be or will be anywhere from 150 to 225 miles away from Dallas. Question 5. Hopefully you've drawn in the line at 7.5 or 7.5. So then we're going to write the answer as an inequality. And everybody should have 0 as their low point because remember, he's there. If he's going 60 miles per hour, he's there after 7.5 hours. Or let's estimate it's a little bit above 90. It's not quite 135, so some of you might have said 100, 105, 110. I've gotten 115. So again, after he's either at Dallas or he has up to 115 miles left to go. He's either there, and you can use whatever numbers you want. If you said 105, 110, 120, that's the number that you would plug in instead of the 115. So then we're going to draw another line segment in at h equals 9. And everybody should have the same numbers for this one because he's either there and he's been there after driving 7.5 hours, okay? Or he has exactly 45 or anywhere up to 45 miles left to go because this is a good intersection point right here at 45. It's not a guessing number. So again, after 9 hours of travel, Travis is either there or he has up to 45 miles left to go. Because if he's driving slower, who knows? Maybe he's only 10 miles away. Maybe he's 30 miles away. 42. We don't know. So number 7 says that there's a region that could be filled in by similar vertical line segments for all hours, all values of h. So we're going to shade in this region. So you're going to have to flip back to your graph. Okay, and we're going to color in. If we keep drawing in vertical lines for 9 hours and 8, 7, 6. So if we keep filling in any hours, 3.5, 5.2 hours, we're going to keep filling this in, and this entire middle section is going to be shaded. So go ahead and color that in on your graph. Question 8 says that Travis likes to stop for a break after driving half the distance to Dallas. So what was the total distance? 450. So let's cut that in half or divide it by 2. And we get 225. So on our graph, we're going to sketch a horizontal line this time that represents half the distance to Dallas. Okay, so I'm going to sketch it right here at 225. So go back to your graph. Highlight the segment of that line. So from here to here, ooh, it's not going to show up. You get the point where they overlap. What is the equation of this line? So it's d for distance equals 225. How much time might remain in the trip when Travis stops for a break? Explain how you know. So I'm going to kind of look with my eyes. Where do they intersect right here? Kind of bring it down. And then where do they intersect right here? Bring it down. So I'm going to say like maybe 3.75 hours to 5 hours. 3.7, 3.6. It's a little over 3.5, a little bigger than 3.5. And these are the two endpoints of your horizontal line where they intersect with our shaded region. After Travis drives 4 hours and 20 minutes at 45 miles per hour, he wonders how much further he has to drive. Answer question A. It's your preference. Would you prefer to use the graph or the equation to determine the answer and explain your choice? Some of you might say the equation because it's more precise. Some of you might say the graph because it's visual, but it's just kind of an estimate. Sometimes we can't tell exactly where 4 hours and 20 minutes would be. Okay, so how much further does Travis have to drive? Well, we are only talking about hours in our graph, so we need to convert 4 hours and 20 minutes just to hours. Okay, just to hours. So 20 minutes divided by there's 60 minutes in an hour. So that's 1/3 of an hour. So it's 4 1/3 hours. But that's kind of hard to plug into my calculator because it's a mixed number. So let's turn this into an improper fraction. So 4 times 3 is 12 plus 1 is 13/3. So let's take this and plug that in. Now, we're plugging it into our equation. Well, do you remember what our equation was? D equals how fast were we driving times the number of hours plus our starting number, our y-intercept. So we're going to put 13 over 3. Go ahead and type that in. And it's roughly 255 miles left to go if he's driving 45 miles per hour. Question 10 at the top of the next page. Number 10, you need to explain how you could use the graph to determine how far Travis might be from Dallas after 6 hours of travel. So think back, what did you draw over and over again in question 4, 5, 6, etc.? So how could you explain it? So we could draw a vertical line that h equals 6, just like we were doing for the other ones. And then you're going to go up and you're going to look in your shaded region or look to where they intersect. The lower line is at 90 miles, right? The intersection point. The higher line is about at 180 miles. So anywhere between 90 and 180. So depending on his speed, Travis is between 90 miles and 180 miles after 6 hours of travel. So he still has between 90 and 180 miles left to get to Dallas. Okay. Question 11. Assuming Travis can average anywhere between 45 miles an hour and 60 miles an hour, is it possible for him to be 300 miles from Dallas after 2 hours of travel? So go ahead and draw in your vertical line or look where 2 hours would be. Try to find your intersection point or your shaded region. And is 300 a possibility within your shaded region? Look really closely at your book. I know that 300 is somewhere between 270 and 315. Is that in my shaded region? No. So this is not possible. Because it's not in our shaded area. It's not in our solution region. Okay, it looks kind of like between like 320 and 360 maybe. 325 and 360. So 300 would not be a possibility for this.